Let's refer back to the lesson video we had on division of surds. And if you remember where we had 5 divided by root 2, the result, because we cannot have a surd at the denominator, so we say that we have to multiply the numerator and the denominator by the denominator, and this will give us 5 root 2 divided by 2. Likewise, 7 root 2 will be 7 over root 2 multiplied by root 2 divided by root 2, and this will give us 7 root 2 divided by 2. Now, what do we observe here? So in general, we can say that a divided by root b, since in mathematics we shouldn't have surds at the denominator, so we multiply. Okay, this will be equated to multiplying the numerator and denominator by the denominator, and this will give us root a root b divided by b. So this is a generalized format of this. However, what if we have, let's say, a divided by a plus root b? Now we notice something now. This is no longer a single surd, but now it's a surd in brackets. And in this video, we are going to look at division of surds in brackets. So the principle here is that we multiply the numerator and the denominator by the conjugate of the denominator, a minus root b, a minus root b, such that when we apply multiplication on the denominator, we would be left with a rational number, because we know that a plus root b multiplied by a minus root b will give us a whole number in terms of a squared. We take the square of the first term and we subtract the square of the second term. All right, so the whole essence, the key now to solving this is to multiply the numerator and denominator by the conjugate of the denominator. Now, to recall a quick recall on conjugate of denominator, if we have a plus root b, just like we did, and a minus root b, because they are conjugates just like we did in the previous video, we know that this will give us a squared minus root b squared. And if it is root a plus root b, or as the case may be, the conjugate of root a plus root b is root a minus root b, and therefore this will give us root a squared as the first term minus the squared of the second term, and it continues like that. So the rule is to multiply the numerator and the denominator by the conjugate of the denominator. Now let's take examples. All right, so we are given 2 divided by 3 root 5 plus 4. Now the division here, it's not a single surd but a surd in brackets. Okay, so therefore we are going to multiply it by, we're going to apply the law of multiplying the numerator and the denominator by the conjugate of the denominator. Now if we have 3 root 5 plus 4, the question is, what is the conjugate? The conjugate therefore will be 3 root 5 minus 4. Remember, we're already changing the arithmetic sign between the two terms. Okay, so therefore where this is done, we multiply the numerator out, so this will give us 3 root 5 minus 4, and we also multiply the denominator out. 3 root 5 plus 4 multiplied by 3 root 5 minus 4. Now therefore with this done now, we know that the denominator in its sense can be simplified as 3 root 5 squared minus 4 squared when we apply the law of a conjugate multiplied by its surd. And the denominator can be said as 2 multiplied by 3 root 5 minus 2 into 4. So it's quite easy. So we say that the denominator will result into 6 root 5 minus 8, and the denominator will result into 3 squared multiplied by 5 minus 16. So we say this is 6 root 5 minus 8, and this will give us 45 minus 16, which is equals to 6 root 5 minus 8 divided by 29. Now we have seen how we transform a surd in brackets to a whole number, because that's the whole essence of division of surds, to ensure that we don't have rational numbers at the denominator, but we have whole numbers at the denominator. Let's take another example. Now we have 6 divided by 2 root 2 minus 1. 6 divided by 2 root 2 minus 1. Now in this case, now we are going to multiply the numerator and the denominator by the conjugate of the denominator. And the conjugate of the denominator is 2 root 2 plus 1, because this is minus, and then 2 root 2 plus 1. And in that case, therefore, we are going to have this to give us 6 multiplied by 2 root 2 plus 1 divided by 2 root 2 minus 1 multiplied by 2 root 2 plus 1. We know how the denominator will fall into place, and this will give us 2 root 2 squared. We dealt with a lot of examples in the previous video, and this will result into 6 into 2 root 2 plus 6 into 1. So our denominator therefore will become 12 root 2 plus 6, and the denominator will be 2 squared multiplied by 2 minus 1. So this will be 12 root 2 plus 6, and 2 squared is 4 multiplied by 2, that's 8 minus 1. So this will be 12 root 2 plus 6 divided by 7. Now we've taken two examples on when the numerator is just a whole number. What if the numerator is also a surd on its own? How do we go about this if the numerator is a surd on its own? So let's take another example, and we have 3 plus root 2 divided by root 5 plus root 3. 3 plus root 2 divided by root 5 plus root 3. Now, just as we have done before, all we just have to do is to multiply the numerator and the denominator by the conjugate of the denominator. The conjugate of root 5 plus root 3 is root 5 minus root 3. So we multiply the numerator and denominator by root 5 minus root 3. Therefore, it will bring them all together, root 5 minus root 3 divided by root 5 plus root 3 multiplied by root 5 minus root 3. Now, with this done now, this numerator reminds us of our lesson 10 that says multiplication of surds in brackets. So therefore, we apply the numerator and say 3 root 5 minus root 3 plus root 2 root 5 minus root 3 divided, and the denominator now will be just conjugate of surds multiplied by each other. Therefore, this will give us root 5 squared minus root 3 squared. So we simplify the numerator, we simplify the denominator, and then the problem is solved. So the numerator now will give us 3 root 5 minus 3 root 3 plus root 2 times 5 minus root 2 times 3, because we are applying the law that says root AB is equals to root A multiplied by root B. However, our denominator will play out to give us 5 minus 3. So in essence, so we are going to have 3 root 5 minus 3 root 3 plus root 10 minus root 6, all divided by 2. So yes, this is our final answer. The whole essence is to ensure that we don't have surds at the denominator, or we have whole number at the denominator. Now we cannot simplify this all further because all are in basic form and they cannot be added all together. Now let's take one more example on this topic. Now we have 2 root 2 plus 3 root 3 divided by 4 root 3 minus 2 root 2. Now to simplify this, you can pause the video now to give it a try, and definitely I'm sure you get it. So this will be 2 root 2 plus 3 root 3 divided by 4 root 3 minus 2 root 2, and we are going to multiply the numerator and the denominator by the conjugate of the denominator, and the conjugate of the denominator is 4 root 3 plus 2 root 2. 4 root 3 plus 2 root 2. So we simplify just as we have done in now lesson 10, where we multiply surds, that's 10 and 11, where we multiply surds in brackets. Okay, this is 2 divided by 4 root 3 minus 2 root 2 multiplied by 4 root 3 plus 2 root 2. So therefore, to simplify this now, we say this will result into 2 root 2 multiplied by 4 root 3 plus 2 root 2, and we have 3 root 3 multiplied by 4 root 3 plus 2 root 2, all divided by, these are conjugate surds, so therefore the result will be 4 root 3 squared minus 2 root 2 squared. Now simplifying further now, let's simplify the numerator. Also, we just skip step and push everything together so as not to make this video that long. So this will be 2 times 4 multiplied by root 2 times root 3. Remember, we're applying the law of surds. Plus 2 times 2. Now we are here multiplying this. 2 times 2 multiplied by 2. And now we are here. So this will give us 3 root 3 multiplied by 4 root 3. So this will be 3 times 4 multiplied by root 3 times 3. And finally, 3 root 3 multiplied by 2 root 2. And that will be plus, or this should be plus also. And that means we'll have 3 multiplied by 2 multiplied by 3 times 2. Now all will be divided by the square of this, and we apply the law of indices just like we've done before. So this will give us 4 squared multiplied by 3, and likewise this would give us 2 squared multiplied by 2. So the numerator therefore is simplified to give us 8 root 6 plus 4 root 4 plus 12 root 9. Okay, and root 9 is 3. Root 4 can be written as 2, and plus 6 here now, plus 6 root 6. And the denominator, this is 4 squared 16 multiplied by 3, 48. 2 squared 4 multiplied by 2, 8. So we can collect the like terms now, or let's just simplify. Plus 8 and plus 36 plus 6 root 6, all divided by 40. So if we simplify now, 8 plus 36 is 44, and 8 root 6 plus 6 root 6 is called will be 14 root 6, or divided by 40. Now this can still be simplified further, and you can leave it the way it is. So if you divide all through by 2, or by 2 should work. So we'll have 22 plus 7 root 6 divided by 20. The whole essence of denominator has been achieved. Now we remember our goal in rationalizing the denominator, where we multiply the numerator and denominator by the conjugate of the denominator. So in the next video, we'll take more examples on division of surds in brackets.